Hello everyone, my name is Amrita. I am from CSE department of AKGEC. Today's topic of discussion is microprogram control unit. Okay, so for the microprogram control unit we should understand what is control unit first. Okay. You can see here these are the main outline of this lecture which we will discuss in this lecture. Introduction to control unit, types of control unit, what is a microprogram control unit. Then we will understand what is micro instruction format. After that we will understand what is address sequencing and what is the meaning of address sequencing. Then we convert instruction into an address by the help of mapping of instruction. Next is microprogram sequence. So these are the main outline of our topics we will discuss in this lecture. Fine. Introduction to control unit. Firstly, we understand what is control unit. Control unit is a part of our central processing unit which control overall operation of the CPU. Okay. So we have these are the main features of control unit. Control unit is the part of computer's central processing unit which directs the operation of processor. It is the responsibility of the control unit to tell the computer's memory, arithmetic logical unit and input-output devices how to respond to the instructions that have been sent to the processor. It fetches internal instructions of the program from the main memory to the processor instruction register, and base of this register contains the control unit generates a control signals that supervises the execution of these instructions. It means the work of control unit is to generate the control signal. These control signal will control the overall operation of the ALU, register and other parts of the CPU. So that we can say control unit is a very important part of our computer system. So now I have tell you what is the use of control unit. Now the question is how we can implement this control unit. What are the ways to implement this control unit? Now we can see in this next slide types of control unit. First is hardwired control unit. In the name you can see hardwired. Hardwired means when the control unit is implemented by the different type of hardware like decoder, multiplexer, flip-flops. These are the hardware components are used to implement the control unit. When the control signals are generated by hardware using conventional logic design techniques, the control unit is said to be hardwired. So, in the case of hardwired, we have hardware to implement control unit, and with the help of hardware we can generate control signals. And the another way of to implement control unit is microprogram control unit. In the case of microprogram, we have a program to generate control signal. The name of the program is known as microprogram, and this microprogram is constituted of different types of micro instruction. You can say the group of micro instruction is known as a microprogram, which is stored in a new type of memory which is known as a control memory. So, these micro instructions are stored in control memory. So, overall signals are generated by the help of a software or a program which is known as a microprogram. A control unit whose binary control variables are stored in memory is called a microprogram control unit. Fine. So, you can see here we can implement our control unit by the help of two ways. First one is your hardwired control unit, where we have different type of hardware to generate control signals, and there is another way which is known as a microprogram control unit, where we have a software or program to generate control signal. But what are the difference between these two type of control unit? In the case of hardwired control unit, we have all the hardwares, so that it is very fast. But the disadvantage of hardwired control unit is that it cannot be modified easily. If we want to modify it, we have to change the hardware also, okay, which is very difficult for us. Now next is microprogram control unit. In this case, we generate the control signal by the help of program, so that it is slow, but we can change or modify in this control unit, because the changes can be done in the program easily, okay. So now we will emphasize on the today's lecture in the microprogram control unit. Now this is the organization of microprogram control unit. By this diagram we can understand how this microprogram control unit works. So that in this diagram you can see here, this is the memory control, which is known as a control memory. Actually what happened, the user programs are stored in a memory which is known as a RAM. This is RAM, and RAM will store what? User program. And in this case we have another memory which is known as a control memory or ROM. In this ROM we will store micro instruction or microprogram. Okay. Now next is your control address register. In this case we are storing micro instruction, and now the what is the use of control address register? Why we use this control address register? Control address register are used to store the address of that micro instruction which is going to execute. Now the question is, why we require a micro instruction to execute? We require this micro instruction to execute because we need to generate control signal for the user program. Okay, for this user program we have to generate micro instruction or execute micro instruction to generate control signal. So that control address register will have the address of this micro instruction which is going to execute. Fine. Now next is, this is the control data register. What is the use of this control data register? Control address register will store the address of the micro instruction. Then we will go to the control memory, because this is the address of your control memory, and we will fetch a micro instruction to execute, so that this instruction will be kept in the control data register. Right? Then this micro instruction will execute it, and then we will have two output from this unit: control word and next address information. Control word is used to generate the control signal, and it will execute the user instruction easily. And for the use of next address information is that it will go to the next address generator or microprogram sequencer. Now this is the main part of our microprogramming control unit: next address generator or microprogram sequencer. It will generate next address generation, it will done, and the next address will be send it to the control address register. Now the question is, next address, how it will generate next address? So it will take some external input as well as some next address information which is come from the previous micro instruction. So by this information it will generate or it will calculate the next address of the micro instruction which is going to execute. After the generating this next address, it will send to the control address register, and then at this address we will go to the control memory, and from this address we will take a micro instruction which is going to execute, and it will kept into the control data register, and after that this instruction will execute it, and after that we will get control word and again next address information. Then this process is going on. After till then all the instruction is not executed. Now the question is, what is microprogram? A sequence of micro instruction constitute a microprogram. Since alteration of the microprogram are not needed once the control unit is in operation, the control memory can be a read-only memory or ROM. ROM words are made permanently during the hardware protection of the unit. The use of a microprogram involves placing all control variables in the words of ROM for use by the control unit through successive read operations. The content of the word in ROM at a given address space specify a micro instruction. So, this is the introduction to the microprogram, how it is differ from our program. This is differ from the user program. So, it is stored in the ROM and user program is stored in the RAM memory. Now, next is micro instruction. What is micro instruction? The group of micro instruction is known as a microprogram. So, a symbolic microprogram can be translated into its binary equivalent by means of a assembler. Each line of the assembly language microprogram defines a symbolic micro instruction. Each symbolic micro instruction is divided into 5 fields. First one is micro operations, CD, BR and AD. It is divided into 4 fields. Now, we can see here the format of the micro instruction. Firstly, we should understand what is the format for the user instruction or computer instruction. You can see here, this is the format for the instruction. We have here I is for direct or indirect bit. If the value of I is 1, it means we are using indirect addressing, and if the value of I is 0, then we will use direct addressing. Now the next 11, 12, 13, 14 bits are used, or 4 bits are used for the opcode. Opcode means operation, which operation is instruction is going to perform. And next one part is your 0 to 10 bits are used for the address part of the instruction. So, we will find out the address or of the operand where this operation will perform. So, this is the instruction format of the user instruction. So, you should understand this is the difference between micro instruction format and this is the computer instruction format. This is a user instruction format. Now, you can see here this is the micro instruction format. In this micro instruction format is totally different from the computer instruction format. You can see here we have 3 micro operations field here, F1, F2 and F3, where we perform 3 micro operations. Now, each micro operation of 3 bits. And now next is CD. See, the meaning of CD is condition for branching, and BR is used for branching. So, we will understand there can be 2 type of branching here. First one is conditional branching and another one is unconditional branching. When there is a unconditional branching, then there will not be any condition here. But if we use conditional branching, then we have to check some condition. For example, we should check the value of accumulator is 0 or not. So, we have to keep some conditions also here. So, we have to check in the case of conditional branching, we have to check some conditions here. Now, this is the last part of the micro instruction format is address. What is the use of address? Address part is used for the branch address. If we are using branching, then this 7-bit of address will show the branch address. Now, this is the 4 computer instruction example. We can see here add, branch, store and exchange, and these are all are the opcode values for this instruction. So, this is the computer instruction or user instructions. but this is the micro instruction format. So this is the difference between these two type of different format. User instructions are used for the user program, and micro instruction is mainly used for the generating the control signals for microprogram control unit. Now, next topic is address sequence. Address sequencing means how next address generator or microprogram sequencer will generate the next address. This is the concept of address sequencing. So, there are 4 ways to generate next address. Okay. Address sequencing capability required in control unit. So, the 4 ways for the generating next address are incrementing CAR or control address register, unconditional or conditional branch depending on status bit condition, mapping from bits of instruction to address or for control memory, and next is facility for subroutine calls and written. So, what are these 4 points mean? We will understand by the help of one diagram. You can see this diagram. You can see here how we can generate next address. So, you can see here this is the control address register. This is a register where we will have next address of the instruction which is going to execute. Now, again you are seeing here multiplexer. Why we required multiplexer here? Multiplexer is required because we have 4 options for next address generation. That's why we have, but we will choose only one option at a time. That's why we require multiplexer here. So, we can see here we have 4:1 multiplexer here, where 4 inputs are there and 1 output is there, and one output is connected to control address register. So, multiplexer will generate a particular output and it will send to the control address register. Now, the question is how we can generate these addresses. What are the ways? So, we have 4 ways to generate this address. You can see here first one is your incrementer. Incrementer means, for example, when we have one address, for example 00 or 1001 or 10, then we will add the address in the incrementer. Okay, then next address will generate here 11 or +1 after the +1. Fine. So, this is the incrementer. By the help of incrementer, we can generate control address address of the control address register. Now, then there is another way is subroutine register. Now, the question is, what is subroutine register? Why we use subroutine? What is the meaning of subroutine here? The meaning of subroutine here is function. In this case, when we are using assembly language, when we use this function subroutine, the function name is subroutine. So, if we calling a particular subroutine, then the return address will be stored in this subroutine register. This is another way to generate a next address in the control address register. So, first one is your incrementer. Second one is your subroutine register, from where we can find out the next address. Okay. Next is the mapping logic. Mapping logic is used to convert the user opcode into a control memory address. So, we will discuss in the next slide what is the meaning of mapping logic. Firstly, we understand here next possibility of address generation. Next possibility of address generation is branch address. You can see here branch. When we are using branching, then this is a possibility we can find out the address from the branching. So, okay, branching can be of 2 types. First one is conditional and unconditional branching can be there. So, if the branching is unconditional, then there is no use to check the status bit here, but if we are using conditional branching, then we have to use check some address bits here. Fine. So, we should understand what is this status bits and what is this branch address. So, it is status bits are those bits which are used to check the condition for the branching. Now, these are the micro operation, which we have seen in the previous slide. F1, F2, F3 are the micro operation which is going to execute, by the help of these micro operation execution we will generate control addresses. So these are the micro operation. In this we have a micro instruction, which address is stored in the control address register, and then this micro instruction will execute it, and we execute micro operations, and we will check the branch address and status bit here, so that next address can be easily generated by the help of next address generator or sequencer. Fine. Now we should understand what is the meaning of mapping of a instruction. You can see here where we have a computer instruction and micro instruction address. In the case of computer instruction, it is divided, instruction is divided into two parts. First one is opcode and another one is address. So, okay, so you can see here there is a 1011 opcode part. Okay, now for this instruction we have to execute micro instructions which are stored in the ROM or control memory. When we execute this micro instruction, control signals will generated and this computer instruction will execute properly. Fine. So we will have to convert this opcode value into micro instruction address value. Now you can see we have 4-bit of opcode value. Now we will add 3 zeros here. We will add this 0 in the starting of the address opcode value, and this 20 after this opcode value. So we will add 3 zeros in the opcode value. So now we have 7-bit of address. 7-bit of address means the size of our control memory or our ROM will be 2 raised to power 7, because 7 bits are used for the address here. So by the help of mapping of instruction, we can convert the opcode value of the computer instruction into micro instruction address. Now we have generated 7-bit address. After this generation of 7-bit address, this address will go to the control address register, and we will get this micro instruction, the micro instruction on this address from the control memory, and it will execute it. You can see here, this is the example. We have this add, AND and LDA, different types of 3 computer instruction. Now this computer instruction, when we want to execute this computer instruction, we have to convert this opcode value into the micro instruction address. For example, we have add instruction, then we will add 3 zeros here, back 1 0 in the front side of the opcode and 2 0 in the back side of the opcode value. Now we will go to this control memory, this because this is this address is generated for the control memory. So this is a control memory address. Then we will go to the control memory and we will find out the routine for the add instruction, computer instruction. Add routine means here micro instruction for the add routines are written, or microprogram for the add computer instruction are written. So when we execute add opcode of the instruction, then this micro instruction will be executed from the control memory, and control signal will be generated for this add instruction. For the AND and LDA, same process will be followed. So this is the example of mapping of instruction. Now the next topic is microprogram sequencer, which is very important topic for our microprogram control unit. The main component of the microprogram control unit is microprogram sequencer. So we can see here again, here we have control address register, which store address of the micro instruction which is going to execute. Now again we have a multiplexer. What is the use of multiplexer? Because we have more than one ways to generate the addresses. That's why we have multiplexer. But at a time, at a particular time, only one way, by the help of one way, we can generate address. So that we are using here multiplexer. We are using here 4:1 multiplexer, where we have two selection lines. Now the way of how we can calculate the addresses. We can calculate address by the help of 4 operations. First one is your incrementer. Incrementer, by the help of incrementer we can generate next address. For example, if this time my address is 3, then next time the address will be 4 if the contents in the instructions are executed in sequence. Okay. So by the help of incrementer we can find out address. Next is your subroutine register, which we have discussed in the previous slides also. In the address sequencing also, subroutine register means we will store the return address here. If particular subroutine or function is called, then we will store the return address in the subroutine register, so that we can find out the next address from the subroutine register also. So this is the another way to find out the address or generate the address. Now, this is a load signal for this subroutine register. When this will be 1, then subroutine register will be loaded. Now, next way is external map. External map is the mapping process. The mapping which we have discussed in the previous slides also, previous discussion also, that mapping process is process by which we can convert opcode values into the micro instruction address. So that directly we can convert this opcode value into micro instruction address, and this is known as a mapping process. So this is the next way to generate the next address generator. And next is the branch address. Next one is your branch address. Now you can see how the branch address is generated. You can see this is the control memory, where we can find out the micro instruction which is going to execute, and this micro instruction is divided into these 4 parts: micro operations, condition, branch and address. Okay. So when we are using branch address, so then it can be 2 type of branching. First is conditional and unconditional branching. If we are using unconditional branching, there is no use to use CD or status bit. There is no use, because we don't want to check any condition here. So okay, and when we are using branch instruction, then we have to use these conditions here, so that these instructions are going to a multiplex. Again we are using a multiplexer, where we are checking the these status bits. It's 1 or 0. If it is 1, then there will be condition satisfied, and then we will branch the instruction. So you can see here one is used for the unconditional branching, one is used for direct indirect addressing, S is used for the sign bit of the accumulator, and Z is used for the checking the value of accumulator is 0 or not. So these basically these status bits we can check, or it can be these there can be this condition for the branch statement, so that after test this there will be input logic from where we can send the selection line to the multiplexer. And you can see here, this is the address of the branch instruction. If we are going to branch giving the branching, then this is the address in the micro instruction which give the branching address. So that in this way microprogram sequencer can generate the next address in the control memory, and we can find out the next address with the help of microprogram sequencer. So microprogram sequencer is a very important component of our microprogram control unit. Okay, I think by the help of this explanation, thank you.